I also kind of want you to know that arithmetic is most like linear functions, and geometric is most like exponential functions. So it helps us exponential. It helps us review kind of two big functions that we've studied this year kind of in a different way. But arithmetic is directly related to linear. There's a constant rate of change. We call it the common difference. And geometric exponential functions, there's a constant ratio, which we call it the common ratio. Oops, common ratio, right? Exponential is what you multiply by each time, powers of 2 or powers of a half or powers of 4. And then linear is like you're adding 2, adding 2, adding 2. But how are they different? How is a sequence different than a function? We know this, right? How is a sequence different than a function? These are sequences, these are functions. How are they different? Why are they not exactly the same? What does their graph look like? A linear graph might look like this. How is that different than my arithmetic sequence graph? Describe it. You don't even have to use the vocabulary. Is that what a sequence graph is going to look like? How is this graph different than this graph? They're different. Yeah. Yeah, these have to have a domain that are the whole integers, right? I can only have term 1, term 2, and term 3. So we call this discrete. We call this continuous, right? I could have things that are in between 1, 2, 3, and 4. I can keep going and go to like the negative x values, -5, -8. Same thing with a geometric. Your graph is kind of going to be that exponential curve versus a connected exponential curve. So linking these two, but knowing that there's a difference between a sequence and a function, I'll try to keep putting this up every day because I really want you to know that difference. All right, so a geometric sequence is a sequence generated by multiplying by a common ratio. So you're multiplying this time. Instead of adding or subtracting, you're multiplying. Multiplying is kind of also dividing. If you multiply by a fraction, it's like dividing by 2, multiplying by a half. So it's kind of multiplying or dividing by a common ratio. R is that common ratio. So if they ask you on the homework or a quiz, find R, you're looking for the common ratio. This is another formula that you're going to have memorized along with arithmetic. It's very similar to arithmetic. So this time the closed formula is written a sub n. This time it's your starting term, which is exactly the same as for arithmetic, but instead of adding our common difference, we're going to multiply by our common ratio n minus 1 times in the exponent. So let's compare that to arithmetic. Arithmetic was you take your starting term and you add your common difference n minus 1 times. This is you're adding something 5 times or 6 times or 7 times, so it goes next to it like a multiplier. But here, if you're multiplying by 2, if you're multiplying by 2 5 times, 5 goes in the exponent. So it's times 2 times 2 times 2 times 2. So I feel like that's an important distinction that the n minus 1 goes in the exponent instead of times n minus 1. And then for recursive, you write it as a sub k equals the term that comes before it times your common ratio, but you have to tell the person where to start. So comma, a sub 1 equals whatever. Very similar to arithmetic. So let's do it together for this example 1. Write formulas for this given geometric sequence. What's our R value here? How do I go from 4 to 8, 8 to 16? R has to be what? 2. So for the closed formula, I'm going to tell them where to start. I want to start at 4, and I want to multiply by my common ratio n minus 1 times. And that just makes it so that you produce 4 when you plug in 1, right? Because 2 to the 0 power would just be 1 right here, and 4 times 1 is 4. When you plug in 2 to get the second term, you're doing 4 times 2 to the first, which would just give you 8, or 4 times 2 squared, which would give you 16. So the recursive formula would be a sub k equals a sub k minus 1 times 2. You multiply times 2 every time, and you just need to tell them begin at 4 as your first term. So since we've done arithmetic, I think the language and the setup should be easier kind of for geometric than arithmetic, because it's your second time applying a formula. So help me write the closed formulas and find a sub 6. How would I write the closed formula for example 2? A sub n equals, so I'm starting at 12, right? What am I multiplying by each time? How do I go from 12 to 36, 36 to 108? My ratio is 3, and I do it as the n minus 1 power. So you are going to plug in 6 and tell me what you get. So I don't know what this is without a calculator. 12 times, this time it would be 3 to the 5th. So type that in and tell me what you get. 12 times 3 to the 5th. Anyone not have a calculator at their desk? I keep stealing them. So take a stab at writing. Be careful with your negatives. Take a stab at writing example 3. Who else has a calculator that doesn't have another desk? Does everyone else have one? Everyone has one now? Yes. Let's see. Our starting value is negative 1/3, and you're going to want to put the negative 1/3 in parentheses so that when you multiply times your ratio, it's going to alternate between negatives and positives, right? What's my ratio? What do I multiply to get positive 1/9 and then negative 1/27? Yeah, so the ratio and the starting term are actually the same, right? And then you could do the n minus 1 power. So that way on the first term, all you get is negative 1/3. But on the second term, negative 1/3 times negative 1/3 gives you that positive 1/9. And then negative 1/3 times negative 1/3 times negative 1/3 again gives you positive 1/27. If you prefer to write it as just negative 1/3 to the nth power, that's the same as when the ratio and the starting term are the same. That's kind of a shortcut. You don't need times n minus 1, because if you just raise this number itself to the first power, you're going to get negative 1/3. And then when you square it, you're going to get positive 1/9. So either of those is fine. We had that same shortcut with arithmetic. So now you're going to plug in a sub 6, and I would just leave it as a fraction. So you're going to have to just take, let's see, 3 to the 5th, wouldn't it be? This is squared, third, fourth. So I guess it is the 6th, right? We're just going to do it to the 6th power. What is 3 to the 6th? Is it 729? And it would be, this would be negative. So this one's going to be positive again, right? So positive 1/729. If you try to just type it in and you do parentheses negative 1/3 raised to the 6th power, it's going to give you that decimal. If you want it to put it back into a fraction, if you hit math and then hit enter for fraction, it'll put it back into the 1/729. But you have to put the negative 1/3 in parentheses so that you get that positive coming out. I think there's one down here that I wanted to show you. They give you the first term, the common ratio. Number 4 is pretty easy. Find the closed formula. All right, number 5. I want to skip to number 5. You can try number 4 in a second. Find the closed formula for a geometric sequence. They give you the first term. Oh, they give you the ratio. So that's easy. I thought there were harder ones on this. I guess the harder ones are on the back page. So we could just do these in order, right? Find the recursive formula if they give you the first term and they give you the common ratio, and then write the first through the fifth terms. I think you can do that one yourself. They give you the first term and they give you the common ratio. So that's pretty easy. Given the sequence, determine if it's in the sequence. So why don't you take a minute by yourself and try 4, 5, and 6, but we'll go over them before we move to the next page together. So I'll give you a minute to try those. We've got find the recursive formula. So a sub k equals a sub k minus 1. The common ratio is 2. So I'm multiplying by 2, and I have to tell them that the first term is 3. And then I have to list 3 is my first term, times 2 is 6, 12, 24. They need 5 terms, 48. Always count this as term 1. So on your quiz, if I say I want the first 5 terms and you list the first 6 terms, I'm going to take a point off because you're not counting that as a term. That counts as term 1. Term 1, 2, 3, 4, 5. So I get a little bit picky because when we get to series, if you add together the first 6 terms instead of the first 5 terms, you're going to get a different answer. They might only want you to add the first 5 terms. So you have to know that's the first 5 terms correctly. The closed formula, a sub n, they're telling you your first term is 20 and you're multiplying by a ratio of 1.05. N minus 1 is in the power. Find the 15th term, so 20 times 1.05 to the 14th power, 39.6 if I rounded it, 39.6 rounded. And then given this sequence, determine if this falls in the sequence or not. I mean, you could do it as guess and check. You could write out the formula. I'm starting at 5 and I'm multiplying by 3, n minus 1 times. So you could plug it into your y equals menu, 5 times 3 to the n minus 1. And did you say it falls or not falls? 3, 6, 4, 5 does fall in the pattern, and it would be what, term 7? 1, 2, 3, 4, 5, yeah. A sub 7. So if you do 5 times 3 to the 6th, you get 3, 6, 4, 5. I plugged it into my y equals menu and just skimmed quick in my table. If you want to try to solve it, what you can do is write 3, 6, 4, 5 equals 5 times 3 to the n minus 1. Divide by 5 on both sides. 3, 6, 4, 5 divided by 5 is 729 equals 3 to the n minus 1. That's a power of 3. So then you could just play around with 3 to what power is 729, kind of like we did in our exponent unit. You don't have to use a log. A log would be if this wasn't a power of 3. All right, I'm going to let you do some guided practice, but I would like to look at number 3 on the back quick. So they're giving you the third term and the fifth term, and you have to find the second term. Remember how we did this with arithmetic? You figured out how many terms have passed and what the total distance was. It's kind of the same for geometric. The third term they're telling you is 64, and the fifth term is 1024. So you could guess and check, right? Is it 64 times 2 times 2? Is it 64 times 3 times 3? You know the ratio is going to be something kind of easy, times 1.5 times 1.5. But if you don't want to guess and check, you could say I'm multiplying by r squared, right? Times the ratio again. So you could write out 64 times r squared equals 1024, right? 64 times r again gives me 1024. Divide by 64 on both sides, 1024 divided by 64. So r squared equals 16, and then you know r would have had to have been 4. So if you don't want to guess and check, you could, maybe this is r cubed, or maybe this is going to be r to the 4th. It depends on how many separated terms you have. I'm just taking the square root here, but you could take the 3rd root or the 4th root, depending on how many r's are getting multiplied. Or you could guess and check. But in this case, they wanted the second term. If r is 4 and you have to go backwards, what would the second term have been? So you have to do 64 divided by 4 to go backwards. Would just be 16. So the second term is 16. So I'll leave you, number 4 is going to be a little bit of a challenge. So if you get stuck on number 4, kind of skip through and see how you do on the rest of kind of the guided practice. If you need a little help on the application problems, let me know, but we'll see if you can answer these. So if you ever don't know the ratio, take your second term and divide by your first term, because it's 4r is 6, so 6 divided by 4 would give you your ratio. So here are the answers to the guided practice. Let me know if you have questions.